One of the most popular defects in molding is the weld line. Well, maybe more unpopular than popular. The big question on your mind is, well, what is a weld line? I mean, what is it exactly? That's a great question. Let's break it down into its simplest elements. In this video, we will try to answer the following question. Number one, what's a weld line? Number two, how is a weld line created? And number three, what can you do to minimize weld lines? Okay, here are the basics. You have a plastic part with a hole or an opening. Material is injected into the part and will have to go around the hole. Okay so far? Let that idea settle in for a few seconds. Let's watch that again. That's a helicopter view of weld lines. Let's look at the tool structure to get a physical feel for the situation. The tool construction will make the concept easier for you to understand. Here's a quick reminder: the plastic part and a hole. The hole is created using a core pen. The core pen creates an obstacle for the plastic material to flow around. Here's the material flow with the core pen. The material bumps into the core pen. It has to go around. Remember the weld line? Weld line happens on the opposite side of the core pen. Let's start to zoom in on the dynamic that happens on the backside of the core pen. Do you see how the material flows meet after going around the pen? So the material zooms around the core pen and creates a natural blind spot. The blind spot plus the material backflow creates an air trap. Here's a quick section through the weld line. You can see the weld line is really a mini slot. Air and gas will get trapped in this slot. This causes a resistance, preventing the total filling of the slot. Let's look at the flow in a different way. Hopefully this is making a little more sense now. We started this conversation with these three questions. You now know what a weld line is, and you have a better grasp of how weld lines are created. That leaves only one question left to investigate. Let's look at the next step in this discussion. How can we improve these types of weld lines? Remember the air trap? This is a clue. How can we reduce or avoid this air trap scenario? So we have the hole in the part which is formed by the core pen. The air trap happens in this area. How do we get the air out of there? How about we create a place for the trapped air to escape to? You can do this by machining a hole into the core pen as shown. This can be done using a CNC cutter or even spark erosion. Then we add a small slot to allow the compressed air to escape into the core pen. This small slot is called a vent. Here's what it looks like in a different view. The width and depth of the red area are dependent on your material flow characteristics. The airflow looks something like this. This approach will improve your weld lines. It may not solve all your weld line issues. What are the main factors that affect weld lines? There are many. A few that come to mind for me are maintaining the material flow front temperature, managing the flow patterns, and the placement of part core out features. Thank you for hanging in there for the full video. Now you know a little more about weld lines, and a lot of the mystery has been removed.